Students, I am Dr. Nimi Singh. Today I bring you the next learning module in BSc Forensic Science on behalf of the content writers, myself and Ms. Tulika Banerjee on an important unit of paper Criminalistics, that is Forensic Significance of the Tool Marks. In this lecture, we will be studying about the tool marks and it being used as evidence in the field of forensics. In addition to it, we will also be studying about the class and the individual characteristics in case of tool marks, its various types and location, its collection, preservation and handling. You will also get to know about the standards collected for the purpose of comparison and how comparison is carried out with the help of the comparison microscope. You will also get to know how examination of tool marks is done from a scene of crime to laboratory. We will then wind up this lecture with a conclusion. Let's have a look at what we are going to learn today. We will first give an introduction to tool marks, then we will study tool marks as an evidence, the class and the individual characteristics, the types of tool marks location, collection, preservation and handling of tool marks, the standards for comparison, then comparison of tool marks by comparison microscope, examination of tool marks, and in the end we will conclude. Now let us come to the introduction of the tool marks. Tool marks are the impressions which are left by a tool on coming in contact with a surface. These tool marks show different types of characteristics depending on the type of impression, its shape and how the mark was created. Depending upon the force with which the marks have been put, the tool marks are now divided into different categories. The examination of tool marks is an important factor in the field of criminalistics as it can directly establish the link between a tool mark and the tool that created it. These impressions also help to reconstruct the crime scene. Let us define a tool now. Now, a tool is nothing but a hard object which, when forcefully made to come in contact with another object, leaves a mark on the softer one like a screwdriver, a plier or an arc joint plier, a hammer and wire cutters, etc. A tool mark is defined as an impression which is left by a tool when it comes into contact with the surface. If the tool contacts the surface with a large force, it leaves behind an indentation and the pattern of the tool is permanently reproduced on the surface. These marks play a vital role in forensic science as the criminals have a tendency to use tools for committing burglaries or other heinous crimes such as cold-blooded murder. For example, if a burglar tries to enter a house by breaking the lock with the help of a screwdriver, the marks left by the tool are a direct evidence of the presence of that tool at the crime scene. But if the tool is found with the suspect or even near the suspect, it provides a direct link between the suspect and the crime scene. In the field of forensic science, the tool marks can either take the form of negative impressions or an aberration or both. Tool marks are a type of physical evidences and it is classified according to how it relates to the act under investigation. An important thought here is the way the individuals involved in the crime have interacted with the environment and with each other also, and the type of evidences produced during these interaction. Physical evidences can be looked at as type of surfaces, that is the substrate or recording medium on which they are present. Accordingly, laboratory examination and interpretation of the evidence allows the forensic scientist to offer an opinion as to what has taken place and how it has taken place. Thus, in other words, the physical evidences are unintentional and somewhat imperfect record of the interactions of the perpetrator and the victim and the environment. Considering physical evidences in this way can be very useful and can yield large dividends in any investigation. Tool marks have two different types of characteristics: class characteristics and individual characteristics. Let us discuss them here one by one. Now, class characteristics are the type of characteristics of a tool mark that include the type of impression, its general shape and dimensions. These characteristics are typically the broad characteristics from which the crime investigator can determine what type of tool created the impression and how was it created. But this does not serve the purpose of the identification of the exact tool that actually created the mark. Thus, if only the class characteristics would have been available, then it would not have been possible to distinguish which tool among a pack of similar tools made an impression. For this, the individual characteristics are taken into consideration. Now, individual characteristics are microscopic characteristics which refer to the small peculiar features exhibited by the tool that are individual to one particular type of tool only. These characteristics include small microscopic ridges and irregularities which are present on the tool itself. For example, the tip of a screwdriver is never exactly flat, but has irregularities near its edges. These characteristics are created by the use and misuse of the tool, its cleaning and maintenance. These characteristics actually permit a formal identification. If such characteristics are available on a tool mark, then it is possible to identify the tool that was used in committing the crime even among a series of identical tools. Depending upon the amount of force with which a tool comes in contact with a softer surface, the tool marks are divided into two different categories. The first one is the impressed tool marks. Now, impressed tool marks occur when the surface onto which the tool comes in contact with is softer in comparison. When the tool comes in contact with the object which is softer than the tool with a huge force in a motion perpendicular to the plane of the surface, it leaves an impression on the surface. Such tool marks are called impressed tool marks. There is no lateral motion. At the crime scene, the unique imperfections of the tools are transferred to the surface that makes possible a positive identification of the tool involved in the crime. As an example, when a tool like a screwdriver is used by the criminal to forcefully indent a metal surface without penetrating it, then the impression it leaves will be helpful in identifying the tool. Then comes the second type, that is the striated tool marks. These marks are produced when the tool contacts an object with a lateral or sideways force. In such a case, the tool is placed against an object and is moved parallel to the object or across the object. Some tool marks can be a combination of the above two types. With these two types of characteristics, various subclasses of evidences can be distinguished and their applications can be used further in crime investigation. Now, coming to the location. Now, the apparent movement or disturbance of various objects is observed, documented and interpreted to reconstruct an event. Then comes the imprints and indentations. Evidence in these categories includes marks in the form of indentations formed by tools, primer marks, breech face marks, pry marks, imprints like track marks formed by tire, gait, pattern, fingerprint, footprints and bite marks. Now, class and individual characteristics of the suspected devices making the imprint or the indentation are compared with the details of the specimen marks produced in the selected recording medium as specimens. This particular type of comparison is usually accomplished by first producing a specimen or exemplar mark in a suitable material at forensic science laboratory and are then compared inter se with evidence marks. Then are the striations. Striations, another type of tool mark, are produced when two surfaces come into sliding contact with each other. The marks resulted from this dynamic process are striations, which in contrast to the static process results in the production of imprints and indentations. Striations are marks consisting of numerous lines separated by grooves, randomly spaced, parallel streaks of varying length and width. Examples of striation mark evidence are produced as markings on bullets, marks made by certain cutting tools, that is a machine tool, wire cutters, thread cutters, bolt cutters, knives and axes, die marks on wires from the drawing operation and extrusion marks on certain plastic and metal articles. Striation marks can be produced in many varied situations where the surface of one object marks the surface of another because one of them is in a motion relative to the other. Certain kinds of marks made by prying tools such as jimmies and screwdrivers where the tool slips across the surface falls in this category. Similarly, some teeth marks or bite marks like those made in biting of a piece of cheese or fruit for example. Striation markings possess both class and individual characteristics which can be useful in the process of identification and individualization. Then is the perforation marks, tears, breaks and cuts. Now, perforation marks are generally punched in a receipt book to separate the counterfoil. Breaks and tears normally provide the largest number of details for potential individualization, but success is sometimes possible in cases of cut pieces as well. In some of these cases, the individualization potential depends less on the nature of the cut, broken or torn surface than on various features on or within the body of the article. Examples of such features include writing, printing, design, surface topography, grain structure, pigmentation patterns and characteristic irregularities. In these types of markings, physical fit or physical matching is carried out for the purpose of comparison and to determine whether they are from the same or different source. Examples of places and surfaces where tool marks can be observed during investigation or are more likely to be found during an investigation includes wires, chains, door and window frames, sections of metal sheets, safes, human bone or a cartilage, padlocks and doorknobs, bolts and locks, etc. The nature of tool marks depend upon the nature of the crime. If the house has been broken open, the tool marks will be found at the point of entry on the locks, safe doors or the almirah. If the telephone, telegraphic, electric or traction wires are stolen, the details of cutting instruments will be found. The stolen parts of vehicle will carry impressions of nails and bolts. The original article bearing the question tool marks should be collected. If not possible, casts of tool marks in sulphur, plasticine, dental cement, etc. should be obtained. While collecting a tool, it is important to preserve the traces on it such as paint, oil or metallic residues. If possible, tool mark evidence is collected. If it is not possible, castings can preserve impressions of the tool marks. The cast impression will retain the unique indentation marks made by a specific tool. A variety of silicone or rubber based casting materials can be used to record impression marks. Surfaces should be examined before casting materials is applied to determine if the area should be dusted for fingerprints. The use of magnetic dusting powder in silicone material allows for fingerprints to be lifted from the surface before impression marks are cast. The size of the impression should be measured and recorded. The evidence should be correctly labeled, wrap small objects with clean paper and place them in small containers or plastic bags, lest destroyed. Pack larger objects in cartons or boxes. Record who collected the evidence, where it was found, when it was found, why the evidence was collected. Maintain the chain of custody. Coming to the standards for comparison. For the purpose of comparison of the tool marks collected from the scene of crime, standard marks are required, which can be obtained from tool mark databases with images acquired by forensic comparison microscopes are being built. Algorithms to statistically analyze tool marks patterns are being developed. Scanning tools are being used to measure the depth or the height of tool marks. If the edge of a tool is scraped against a softer surface, it may cut a series of striated lines that reflect the pattern of the tool's edge. With the aid of a comparison microscope, markings left in this manner can be compared in the laboratory with test tool marks made from the suspect tool. When a sufficient number of striations match between the evidence and test markings, the result can be positive comparison and hence a definitive association of the tool with the evidence marks. A major problem of tool mark comparisons is that the difficulty in duplicating in the laboratory the tool mark left at the crime scene. A thorough comparison requires preparing a series of test marks by applying the suspect tool at various angles and pressures to a softer metal surface. For this purpose, lead is commonly used. This approach gives the examiner ample opportunities to duplicate many of the details of the original evidence markings. Examination and comparison of the tool marks from a crime scene with the tool marks of the actual suspected tool can act as the important and invaluable evidence in linking the suspect to a particular crime, and thus the case can be concluded. The major precautions that are to be taken while examining the tool marks include door and windows and other openings with handles or locks at the crime scene should not be touched if they are broken or the locks are cut, lest the tool marks or the fingerprints are destroyed. Secondly, a tool should not be fitted forcibly into the impression, which may affect the laboratory analysis. The tool marks should be documented completely, including sketches and photographs before removal. If any trace evidence is found on the tool marks, the examination of the trace evidence should be done prior to tool mark examination. Tool marks evidence should be packaged so that it is not damaged, as it may change the microscopic or the individual characteristics. If the tools are stained with blood or some other biological material, then that has to be cleaned using a soft bristle brush and disinfectants like turgesine, ethanol, etc. The tools are always cleaned with cotton tipped swabs saturated with ethanol or acetone. The tool mark examination and matching consist of different phases. So, the first step is to observe some physical feature of the tool, that is the manufacturer, the type of tool, the composition and the color. Then the condition of the tool's finish, the dimensions of the tool, that is the overall length, width, etc. Any irregularity at the ends of the tool. Then comes the next step. So, the next step is to observe the physical features of the tool marks, that is the type of the tool mark, the width or the diameter of the tool mark, the type of cutting motion by the tool, the direction of motion of the tool that created the tool mark, position of the tool mark on the tool. Then a photograph of the impression made by the tool is taken, which provides a permanent record of some of the characteristics of the tool mark. If the carrier or the object where the tool mark is located cannot be collected as an evidence, then a cast of the tool mark is made with a dental paste. After discovering the tool, if its class characteristics match with those exhibited by the tool mark under consideration, then the comparison process can be started. The tool is observed and a photograph is taken, and then the comparison tool marks are made of a softer surface. The comparison is then done between the comparison tool marks and the tool marks under investigation using a comparison microscope, which consists of two microscopes which are connected with each other with two objects can be viewed simultaneously with the same degree of magnification. If a match exists, then the common region between the two tools is established, which then leads to a conclusive report of the case. Tool mark evidence is most commonly found in cases of breaking and entering, theft, assault and homicide. The goal of tool mark analysis is to determine if a particular tool produced a particular mark or not. Due to manufacturing processes and wear from use, tools can bear unique microscopic characteristics, allowing their marks to be positively identified as originating from that specific tool. Let us read from the table some of the common tools that are used and what is the common evidence that is received. For example, pry bars, the evidence is locks, screwdrivers, safes, drill bits, window sills, hammers, door frames, knives, doorknobs, pliers, the channel locks. The examination of tool marks is conducted in different phases. First, the tool mark is observed, measured and described. Second, a photograph perpendicular to the tool mark is taken. This provides a permanent record of the class and some individual characteristics of the tool mark. When a tool is discovered and its class characteristics match the ones exhibited by the tool mark, then the comparison process is started. Usually, the tool is observed and photographed. The examination of tool marks is conducted in different phases. First, the tool mark is observed, measured and described. Second, a photograph perpendicular to the tool marks is taken. This provides a permanent record of the class and some individual characteristics of the tool mark. When a tool is discovered and its class characteristics match the ones which are exhibited by the tool mark, the comparison process is then started. Usually, the tool is observed and photographed. Then, comparison tool marks are made with the tool on a soft material so that extra marks are not created on the tool. A comparison microscope is then used to perform the comparison process. The incriminated tool mark is placed on the left side of the microscope and the comparison mark on the right side. If a match exists between the individual characteristics, the common origin between the incriminated tool mark and the tool mark is established. Tool mark comparison and identification are typically performed on the following types of evidence. That is the test marks from an evidence tool compared to tool marks on evidence items recovered from a crime scene to determine if the evidence tool marked the evidence item. Evidence tool marks recovered from the multiple crime scenes to determine if the scenes are related to a single tool or not. To maximize effectiveness and efficiency when producing test marks as a basis for comparison against tool mark made by an evidence tool, a number of variables must be considered. The manner in which the tool acted on a tool marked surface, that is the action employed, the areas of the tool's operating surface that was used, the amount of force used on the tool, the direction in which the operating surface of the tool moved. With some tools, this may be very limited, like bolt cutters. With other tools, there may be nearly unlimited directions, that is like a screwdriver. The angle or orientation of the tool relative to the marked surface, the physical circumstances of the crime scene that may limit how a tool could be used. For example, a wall adjacent to a door lock that forces a tool of a given size to be used in a particular orientation. Coming to the photography of the tool marks. Two types of photography are necessary for courtroom presentation as well as for investigative process. Overall photos depicting the entire crime scene and the object that be as a tool mark. Then you have close-up photos showing the details of the tool mark. These photos should contain a scale and are used for identification and orientation only. Let us now conclude our lecture by a summary of what we have done. A tool mark is defined as an impression which is left by a tool when it comes into contact with the surface. If the tool contacts the surface with a large force, it leaves behind an indentation and the pattern of the tool is permanently reproduced on the surface. These marks created on the surface can be linked to a particular crime or with the suspect, victim and scene of crime. They are of utmost importance in the field of forensics and hence should not be overlooked. With all these information here, we come to an end of today's lecture. Do keep in mind what we discussed today. I will be back again with one more lecture in this series. If you want to learn more and enhance your knowledge, you may log on to our website www.cec.nic.in for MCQs, quizzes, LORs, etc. Thank you for your time today. I will see you in the next lecture. Have a great day.